into stuff that was outside of the BI and data warehouse wheelhouse. And then we had a business problem that we couldn't solve in-house. And I'll just describe it really briefly. And that's the reason why I got interested in these technologies that I'm going to present on. At this last company, we had a situation where we had an opportunity to sell a big data set to a data partner. And the long and short of it is it would require so much processing to prepare the data set just using SQL that we estimated it would take 58 days to do it on the data warehouse. And we all decided that was a good 56 days too much. So we said, we've got to do something entirely different. We can't just optimize our SQL and or parallelize it. It's just not going to happen on the SQL Server data warehouse. So what do we do? So this is when I started hearing about, well, Daniel, you need to look into Presto, look into Glue, look into S3 more. I was already familiar with S3 and see what can be done there. And the long and short of it is we decided that we would do three things. First of all, the part that I wasn't capable of doing at all myself was the Spark. So we happened to have a Spark Java guy that did the geospatial part of that processing, which was probably a good third of the amount of processing that needed to be done just to do geospatial processing. He did in Java, and I don't do Java, so I was just smart enough to find a guy that could do all of that. But then the other 2/3 of it was all SQL stuff. And as I started reading about Presto, I started thinking, gosh, so all I have to do with this SQL is, sure, I have to optimize it, but I have to define partition keys, and we can farm this off to Presto. We can spin up like an 8-node Presto cluster on Amazon in Elastic MapReduce, and we can distribute that query. First of all, we can pull all the data out of the SQL warehouse with no transformations at all. It was only a year worth of data, landed in S3 using Presto, and then we will do all of the heavy processing from S3 using Presto SQL. And I'm like, wow, that's awesome. So started doing that, and the long and short of that, oh, and by the way, we're also using Glue because we needed to have a Hive metastore. So we were using Glue, and I didn't know much about Glue at the time, but I understood the idea of cataloging the data so that we could do SQL queries against S3. So it was still a lot of SQL and a lot of work, but we really were able to reduce the processing time down to what we projected to be 58 days, down to less than 3 days, simply by moving it off of the on-prem database, moving it into the S3 data lake and processing it massively with Presto. I think we had 8 nodes in the Presto cluster, and I don't know how many nodes were in the Spark cluster, but the whole thing took 2 days, and it was marvelous to see that work. So since then, I decided I'm going to get smarter on this stuff, and I've gotten a little bit smarter, and I want to show you what I've learned and share with you what I've learned because I'm really appreciating this technology. So my interest in this became, well, I want to see what I can do on Amazon in a serverless way. So I want to look at Aurora DB, which is their serverless relational database service. I can use MySQL or Postgres. I want to use Glue, which is basically, this is what I'm going to be talking about, but Glue is a serverless ETL data cataloging and ETL engine. I want to use Athena, which is a serverless Presto instance, basically, that will query S3 through a Hive metastore. And then I want to play with QuickSight to see if it even comes close to Tableau, which it does not, by the way. But it is an interesting serverless data visualization tool in Amazon that's kind of new, kind of like maybe Tableau was 12 years ago or something like that in terms of sophistication. So this presentation here is all about Glue and nothing else of what I just said. So what is Glue? Glue.
Were you ready to share your screen, Daniel?
I can. I don't. I think I'm ready to share it in about 1 minute.
Okay.
All right,
Just
Dustin?
let us know if you have trouble. Is all I was worried about.
Sure.
All right,
Okay. Yeah. So I will share that, and I'll probably leave it shared for a good amount of the time after that. But thanks for reminding me. So Glue was built on what's called the Hive metastore for Presto, and particularly I'm talking about the Glue data catalog. Okay. I'll get into what that does, but it's built on Apache Hive Metastore. Um, the Glue version of that has a crawler, and it can crawl any number of databases and capture all of the metadata that you would want and make it directly queryable. So you can write queries from the Glue data catalog, and it'll pull directly from the actual data store, sort of a pass-through. And then it also has an ETL engine, which uses either PySpark for either Spark, I should say, for big jobs, or a Python shell if you have smaller jobs and you don't need to have the muscle of Spark. Glue is, oh, and yeah, I already said that the Glue ETL engine is fundamentally based on Spark, but also a Python shell will run on it. Fundamentally, Glue is completely serverless unless you determine that you need to have an endpoint in Amazon, meaning you need to have a test or dev environment in which, for instance, if you're doing Python shell stuff, I wouldn't be comfortable doing that in Glue and then seeing if it runs. I want to put it into a shell where I can run it and test it without having it be a part of ETL. So in that case, and maybe I'm getting into too much detail right now, but in that case, you might instantiate an endpoint, which is a host, and therefore it's a server, and that's not serverless. But you don't have to do that. In its essence and in production, Glue is completely serverless, okay? You don't manage, own any operating systems, any hardware, certainly no hardware, nor even any applications. You don't manage you don't configure and you use the Glue application, but you don't manage it, install it, upgrade it, patch it, nothing. It's all serverless, which is pretty compelling in my mind. So that's how I got interested in this. So what I'm going to do now is share my screen, and I'll start to show you some context that we're going to go through here. And so here I go, sharing my screen right there. Bang. So can everybody see my little diagram, my color diagram?
Yep, coming through.
Good, very good. All right, so let's go into a little more detail. I don't have a whole bunch of really slick slides to show you here. It's mostly discussion and showing you screenshots and so forth. So what is I can actually go down that little checklist right there that I wrote up. This was all put into my blog, which you can find on Decision Lab, on either Decision Lab, my website, or on my LinkedIn feed. But this blog I published last week. So you've got the basic architecture of Glue is that, yes, it's usually operating in a larger context, clearly involving S3, oftentimes involving a data store either in Amazon or on-prem. It's got its crawler, it's got its ETL engine, which, as I said, runs Spark. And then it's got the target data where it sends it to. So a typical sort of workflow, or not workflow, but process, if you will, with Glue, just in a nutshell, is like it says in number 1, you would crawl a data store such as maybe an on-prem SQL Server or an on-prem Oracle. You would crawl that to capture all of the metadata that you need in terms of what's the path, what's the table, what's the database name, the table name, the field data type, etc. And you crawl that, and all of that loads automatically into your Glue data catalog. And then you do that for any other database or flat files you need to, because you can be crawling and cataloging other stuff besides just relational. And we'll get into that more. So at a high level, now you've crawled it, and now you're going to move data from it. So, and this is something I'd like to discuss if others have opinions on this, as to whether Glue is a good engine to actually pull data out of on-prem and put it into S3. I think we should have that discussion. But you certainly can do that. So you would then set up an ETL job to pull the data by querying through this new Glue data catalog that you just crawled, or that you just created with your crawl, and load it. The standard place would be loaded into S3, perhaps in a raw layer, okay? And I'll speed this up a little bit because I don't want to get too wordy, but then you would recrawl what's in the S3 layer, because you want to query that in your ETL to do more transformations. So you do a new crawler on S3, and then you do more ETL from S3, and you might put it into an S3 prepared layer in whatever way you want, okay? And in doing that, We're going to go in deep into all of those things, but that's basically it, except for at the end of a workflow, which I will describe, which is a series of jobs and triggers. You would then recrawl everything just to get updates, because this data catalog will certainly store history of your versions. So now I'm going to give you just some super quick context for what we're looking at. Yeah, there's a big MySQL database that I'm using, or rather one with a lot of tables, but we're just going to look at 6 tables and really just focus on one table. So pretty simple schema right here. The reason I'm bringing this up now is because you can see in this actual MySQL database, there's several more tables and there's a bunch of views, which you've got to decide on in the crawler, whether you're going to pull them all in, okay? So in our case, we're not going to pull them all in. So let me just scroll down a little further here. And I think what we'll do now is we'll just go straight hands-on right into the Glue console and get into the fun part here. Okay, and let me just bring that up here. Boom, okay. Earlier today, I was having a little trouble navigating around to my workflow, but I can see that's working now. So let's take a quick look at the interface. This is obviously in the AWS console, all right? And under services, you go here, you look for everything, you scroll down to analytics. Sorry, is that over to the right? Here it is, and there's Glue right there, a whole bunch of stuff, okay? In my case, I'm already there. So you get to the Glue console. Down the left side, you've got your data catalog here. You've got your ETL here. Your crawlers are right here. Your databases, this is something I want to briefly mention here. So whether you have flat files or relational tables, JSON, Parquet, whatever, Glue can crawl a whole bunch of those things, automatically classify them, and land them in your data catalog with what's called a classifier that allows SQL querying to happen on it, which is pretty amazing. Not to get off topic here, but what does that mean? So what is a table in Glue? A table is either the equivalent of or rather in the Glue data catalog. It's a pointer either to a relational table or to a flat file, okay? Or to a not flat file, to a semi-structured file. So that's pretty straightforward, and you can see you've got the path to exactly where they are. In this case, the path goes to the Relational Database Services RDS Aurora DB, which is a MySQL DB running this database, which I've got a MySQL workbench on my desktop looking at that as its backend. You can see the classification. Some of this stuff is Parquet, some of it's MySQL, some of it is unknown. Let's see, somebody wants to get in on the waiting room, Andrew, so I guess I'll just click, oh, maybe you already clicked admit there. And more importantly, what's a database in the Glue data catalog? The answer is it's really nothing. It's just a folder where a group of tables or files is. It's just really a grouping, and I'll show you why it is that way. First of all, it's not all relational databases here. But when you look at tables, you're looking at from all different databases, from multiple databases here. See, if I remove this filter right here, now you're looking at tables in all different databases. See that? So when you click on database, and you click on the one you care about, and you click view tables, all you've done is put a little filter right here saying only show me tables in this folder. So if you had a MySQL database and a CSV file that between the two of them, there's a field that will work as a foreign key. You got to join. It's a piece of cake. The join is done. You join them as just as if they were both in the same relational table. If that's whether you're using Athena, Redshift Spectrum, or using Glue to do more ETL. Okay, it's all just joinable as if it was a relational table. So below that, we've got crawlers, which we're going to get more into. Then we've got ETL, which is broken down in terms of jobs. This was the core thing that Glue created at first, kind of like a more data engineering version of Alteryx, if you will. Well, that's not a great analogy. But then in the last year or so, they've added triggers and workflows. When you get to workflows like this is where you see, these are jobs right here, these items. These are triggers. Here's a trigger that started the whole workflow. This is what's called an all trigger. I set up 3 parallel jobs here. And this trigger says, wait till all 3 of those are done and then do this one here, which in this case is a table dependent on 3 of them. And so you can see you can do parallel processing. And then at the end, I've got a glue crawler, which is going to recrawl everything and check for any schema changes and catalog them. Okay, typical type of workflow. This part is the easy part. The more interesting part is the crawlers and the jobs. So that's where we'll focus on. But first, are there any questions so far? Because the rest of the stuff I'm going to go through, I can move it to more of a Q&A process. I can see I won't be done in 20 minutes, but 25, 30-ish minutes. So are there any questions now that we could talk about before I move on?
So we got one in chat that says, is there a free tier on this service?
Yes, there is. There sure is. And here's my other answer to that. Does that look free to you? So there's a free tier and you can use Glue. The place where I found that I was using up actual money, as you can see here, is with RDS. S3 has come in super cheap. The Glue stuff I've been doing, even with PySpark, is super cheap. But the RDS stuff is expensive. It's costing me about $2 a day, which I'll shut down in a couple weeks. I mean, I'm getting a lot of learning going, so 30 or even $60 a month is okay for me. I wouldn't want to leave it all year long, of course, but for this training period I'm going through, it's fine. So yes, it's part of free tier, but once you really get going with some data, you'll spend a little bit of money. But if you're careful, I bet you can keep it at $30 per month or less. And by the way, you always want to click here, right click My Billing Dashboard, and have that as one of your favorite things to check multiple times per day, because that's what I'm looking at right here. And you can even set budget alerts as well to tell you, am I over budget for the costs I was projecting? So any other questions before I move on?
Got a few in chat I can kind of throw out there for you. So
Yeah, go right
one is a
ahead.
comment that I completely agree with, which was, I found setting up the crawler on data sets to initially be a lot of steps that was a little confusing. Would you agree with that one, Daniel? Or
I went through it as part of an online training process with Pluralsight, and I found that it was very straightforward, but it was very artificial as well because I was guided through it by an instructor. So when I threw off
So you didn't
the,
hit the nasty permissions errors I hit as soon as I did it in the real world?
I didn't because I got trained in advance.
Nice.
But once I kicked off the what's it called, the kiddie wheels, whatever they're called, the training wheels, it took me a while to get used to it, and even more so to get used to the ETL part. But we'll go through that part. Any other questions in the chat?
We had two I'll throw out there together. You can decide if you want to just kind of lump them together. You kind of talked about it, but how many days did it take to get the on-prem data into AWS? And can it be used to crawl and catalog external databases that are not on AWS?
Okay, ask me okay, in this case, this is a really small data set. This is not production. This is a tiny little data set. So it only took minutes to load it. Okay, so I don't yet have experience. Wait, are you talking about back at the big one last year? It's at my previous employer. Or are you talking about my personal training? As far
Yeah,
as
they're
how long?
talking about what you're talking about earlier. That I think actually importing data, not
Oh,
the crawling, right?
gotcha. To pull it off of the on-prem database took oh my gosh, it took like 5 hours, 4 or 5 hours. But then to pull it up again off of Presto and do all the massive processing is what took like 2 days. Okay. So that's answer to that question. Regarding the question about, would you repeat the second question, Dustin?
Yeah. Can it be used to crawl and catalog external databases that are not on AWS?
Yes. In fact, in the documentation, which is really good, I'm finding this is the answer. I knew I was going to get that question, so I'm ready for you. It'll automatically crawl S3 and DynamoDB as what they call a native interface, and then it'll crawl a subset of JDBC connections, including all of these: Redshift, anything in RDS, including Aurora, plus on-prem SQL Server, MySQL, Oracle, and Postgres. That's what it'll crawl. It will not crawl, as far as I know, Snowflake. I've seen discussion threads where people were bemoaning that. Now, maybe if there is an ability to build what's called a custom classifier, and maybe that would be the answer, I do not know. But just because you have a JDBC connection, just because you have a platform that will connect JDBC does not mean you can crawl it in Glue. So you have to do some research first. Fortunately, the one I was using, SQL Server, is crawlable, and that was a huge, huge time saver. You can enter data manually, but oh my God, who wants to do that? Enter table and field properties and stuff. That would be a project in and of itself. Okay, so with that, I'm going to move on, and I'm 20 plus minutes in now. I could probably go another 10 minutes. What do you guys think?
Let's go another 10 minutes. That
Okay.
sounds great.
Right, let's do that. So I'm going to have to get real specific here. So let's see here. I talked about connecting. You obviously need to have a connection. I want to get into exclude patterns. So I'm just going to go ahead and go into a crawler and start to add one here, make this kind of interactive, and we'll see what we get into, okay? So we're going to use a connection that I already have, okay? That's easy enough to figure out how to build a connection, right? In this case, the crawler is going to source itself from a data store, not the Glue catalog itself. You can do that. Okay, in this case, it's going to crawl from S3. I can also crawl from some JDBCs and clearly the Dynamo. We'll keep this one simple. It's in my account, not someone else's account. In this case, I would put the S3 path right here. This next part is very important. It's the exclude patterns. If you don't have a perfectly structured S3 set of a bucket with perfectly structured folders where you could simply point to a subdirectory and say, crawl everything, then you need to put in exclude patterns to get rid of some stuff. And I'm going to show you some examples of those. It's actually quite easy to do, but it's something I can show you, so I will. Let me bring up my, I'm not going to try to do it on the screen because it just takes too much typing. So momentarily, there we go. So you probably don't remember, but in that database, there was a field, there was some table called actor, there was another called actor film, and there was another one called genre actor, or something like that, I can't remember. So by putting the asterisk there, the pattern is any table or view that includes the string ACT is gone. You put the asterisk before, that means anything started with it. Rather, anything ending with it. If you put it at the end, it's anything starting with it. It's really just that simple. Be aware that if you don't exclude all of the patterns, including all of the views that you have in your relational database, you will get them all cataloged, and you might not have wanted that. Now, some of your catalogs you might have wanted to have cataloged. Others, maybe not. Understand that, okay, that's enough for this little slide here. Understand that the Glue catalog does not know the difference once it's cataloged between a table and a view. It's all the same thing. It's just a pointer to an object. So if you've got a great Glue, if you've got a great view, it does make sense to go ahead and catalog it if it's something that's really useful. It's available. Okay, so I will see if I can, I don't know how far I can go without entering stuff. No, I probably can't go very far. So I'm going to go back to stuff I've already done and show you what it looks like there, just in the interest of time, since this is supposed to be a little bit abbreviated here. So let's see, am I on a crawler here? Yes, I am. So in this case, this describes the crawler that I would have just built, okay? There's an interesting thing here called a prefix. This is kind of a handy little ETL or schema tool. If you're pulling stuff from S3 or from raw or from on-prem, this would be a great place to put the prefix in that says either on-prem or stage or something that signifies once it lands, what's it about? Where does it come from? So you put in a prefix and it describes that, okay? You can see the include path here, which actually is prompted just before the exclude, is what's included in this target? Is it every single thing in the Sakilla database? In this case, yes, it is. In MySQL, /% means everything. And in this case, I did not put excludes into this particular crawler here. Okay, I'm going to move on here. I won't go into the the verbiage, which is all in my blog, but there's some interesting configurations to do here. After you build out your, or as you're building out your crawler, you have to decide what to do once schema changes are detected. So the natural or the default thing to do would be to update the definition, okay? You can also set it to ignore and do not update if there is a change. You can even set it to ignore it if there's a deletion. The default thing would be to simply mark the table as being deprecated, make a note to yourself that somebody needs to research what's happening once this table is deprecated. Or you might even have an environment in which you want to delete tables where there was a change. It's up to you as the data engineer. So let's see here. That's probably as much time as I have right now to go through the crawler. I really want to get to the ETL. So for just a moment, I'll get back to the, I'll close this out. Here's your handy dandy thing here. If you don't want to go back or next and you just want to get out of it, you just click right there and you're back to the interface. So after the crawler runs, you're just going to see a bunch more tables. So you click on your database, you say, yep, that's the database I said I wanted to look at. Here's my tables. Good deal. I've got tables, in this case, that I added an S3 prefix to, okay? Meaning this table's already in S3. So just be aware when you're querying it, you're querying S3 versus it being in the relational database over here. Okay, so what is there to say about crawlers? I'm sure there's plenty, but I need to switch over to the ETL itself. The ETL, as a reminder, pulls straight out of the data catalog. It doesn't have to, by the way. You can do ETL and Glue from other sources, but the really awesome way to do it is to first crawl them, get them cataloged, and then use Glue ETL to pull from that catalog, through that catalog from all of your data sources, which is pretty much, if I understand it, how Hive Metastore works as well, at least the Hive Metastore for Presto. So you can query this by, oh, sorry, I'm getting off topic here. Yes, you could query with Athena or Presto, but we're not talking about that. So let's talk about ETL now, okay? So I will start by the jobs. All right, let's look at one that I did document already. Obviously, I can start by just adding a job, and we'll see how far we get talking about it before it prompts me that I don't have enough information here. There's some good stuff to talk about here. To answer the first question, yeah, or the question that happened before, yeah, you definitely need to have an IAM role, identity and access management role, that's going to allow this job to get either read or write access where it needs it, okay? In this case, this one is identified as being in the Ohio East region. It's the Glue role that has read access in S3 and write access in S3. So it's authorized to do it. And yes, my first time I absolutely leaned on the teacher, just did whatever the teacher said and it worked. Because the IAM stuff, I'm still getting used to it. It works well, but it's a big bucket, and I'm sort of just kind of dipping my toes in. More importantly, the first important decision you make with ETL is what kind of ETL am I doing here? Am I doing Spark ETL? Am I doing Python shell ETL? That's a huge difference. Am I doing Spark streaming ETL? Well, I personally am not because I don't know how to do that, but I can do Spark and Python shell ETL. The Spark ETL is more built out in Glue than the Python shell is. The next thing to ask is, well, if I'm doing Spark, what versions? I'm using the Spark 2.4 and Python 3, which is still part of this Glue 1.0 version. Okay, the next thing is stuff we love to hear when we don't want to be hand coding, and that is, you only see this with Spark, a proposed script will be generated by Glue. Woohoo! Okay, it's the Spark script preparation wizard. Okay, so now you're going to give the script a name because your script itself will be stored in S3. This is the path where it's going to be stored at. There's a temp directory that gets created for processing. There's only a few things in these other options I want to talk about, but some of them are very important, okay? If you have a library of Python scripts, this is where you would be accessing it, and you could pull it and lay these right into your Glue job. I'm not doing that, but you can do that. Here, worker type, and again, we're in Spark right now. Worker type standard means basically one node, okay? And however, your node can have any number of what's called DPUs. I want to say it's digital processing unit, but I have the data on what it is. But let me think about this for a second here. It's important, so let me get it right and just show you what wrote up in the blog about that because it drives cost, okay? So let me get, oh, here we go a little past here. Sorry, I'm really messing with your eyeballs here. Let me do the scrolling off your screen. I'll bring it back in just a moment here. Now I'll find it. Oh, excuse me, a DPU is a data processing unit. Here we go. Okay, there, I'm saving your eyeballs. Okay, so a moment ago, it was asking us how many, what's the capacity we're gonna use? Meaning how much processing muscle are we gonna use and what are we gonna pay for, right? The default is 10, and that means 10 DPUs, data processing units, okay? A DPU equals 4 virtual CPUs, which in my mind, I think that means 4 cores, I'm not exactly sure, and 16 gigs of RAM. So that's a pretty small Spark job, but that's only one DPU, and the default is 10, okay? By the way, you can't do 1. The smallest you can do is 2, so now you're getting some muscle going. And the maximum you could do is really, how much money do you have, okay? I was able to put 299 up, and thank God I didn't try to run it, but you can spend as much money as you want. You know, Amazon has got you covered, all right? With that, I'll go back to the interface and whoops here, I'm trying to move my thing off here. So that's what capacity means here. It means how many DPUs. So the minimum you can put in is 2, which I love that number. And the minimum processing time for a Spark-based glue job is 10 minutes, okay? Now, it's pretty cheap. When you're only processing a small amount, it's still pretty cheap. I didn't find like I spent a bunch of money by running a tiny Spark job. It did not happen. And also, just because you put in 10 or 100 doesn't mean it's going to spin that many up. What that means is that's the maximum that it will spin up. So you don't pay for Spark node spin up time or spin down time. According to Amazon, you only pay for actual processing time. What else do we want to talk about here? There's some interesting stuff here.
We did have a request for you to talk about scheduling or triggers within Glue. If you're
sure, then I will get to that. I'm going to make a couple more comments on this, and then I'll get right to it. That's pretty cool stuff. So let me cover one more thing here. You don't have to have, oops, where was I on a standard? Hold on here. Name, type, Spark, path, sorry. There it is, standard. You know, in the big world, we don't want to do standard. We want to go with a big machine, right? And rather than having 1 worker, let's go with 299 workers, okay? And now we've got 1 node that's a controller and 299 worker nodes, okay? Yeah, we're ready to do some heavy processing here, okay? And that would obviously cost a ton of money, which I'm not going to do, but that's the maximum number. 299 workers, and this 300 in my mind means there's a controller too. So, okay, I'll back off of that. And let's just say that I built this job, just to kind of get back to the larger context. So I built this job. There is a script which is worth taking a quick peek at before we get to the workflows. That's critical. So I want to take a moment here. So I'm going to click here. Instead of edit the job like I was, which is the parameters, we're going to look at the script itself, okay? Interestingly enough, this diagram will point me towards different parts of the PySpark script. This was PySpark, not, you could also do Scala Spark here, but I'm doing PySpark. And this was auto-generated by the system. We won't have time to get into all the stuff you can do, but there's a whole number of built-in transforms that you can do for Spark. PySpark, and I'm sure there are for Scala Spark, probably even more. And they're different kinds. What's the source, what's the target, what's the transform, and so forth. What you need to know about this script here, even though it was auto-generated, is this diagram here is completely driven by these. Watch, if I screw it up, the diagram will go away. These green lines, which are comment lines, is what creates this diagram. So if you do a script that's great and it works, and you don't want to do all of this commenting to get the diagram right, your script is fine. You just won't be able to talk to people and walk them through it like this, okay? You won't have a nifty diagram, but your script will be fine. So when you work in Python shell, there is no such thing as either this diagram nor any of this automatic transform modularity. It's a shell script and that's it, which is why I was saying if you're doing, oh, you know what I totally forgot to say, I'll get to that in a minute, but if you're doing shell scripting, you're doing Python hand coding. So I think you either want to have one of these dev test endpoints in Amazon. One of them is called the Zeppelin Notebook, which you could run your Python for basic stuff. And then that machine itself is a real machine. It's not serverless, and you'll pay for it as long as it's existing, not just while you're running stuff, but when it's existing. So maybe when your dev cycle is done, like your sprint or your release is done, you might shut off that endpoint until you need it again. Okay, that's one of the downsides of having a Python shell is that you are not, if you're going to use Amazon for your scripting and you need a dev environment, you'll pay for it. Okay, so now with that, let's just say we ran this thing, it worked, and we did it for several more of these tables. All 6 of those tables I mentioned, we created a job and we ran them and they were all successful, okay? Or they were all broken and then we fixed them all, okay? So now, it's interestingly that it wasn't until fairly recently that Glue added workflow, which is kind of like, without a workflow, it's like, really? You're calling it an ETL tool, but it won't even orchestrate multiple jobs? What is this, like a manual thing where people sit around waiting for one to finish and then running another? That's not orchestration. So it was, I think, in the last year that they added workflows. So the core piece of the ETL is still the job. That's the rocket science part. But jobs are kicked off by triggers, okay? I mentioned this before. There's a trigger right there. That's an any trigger. Of course, that means when this job is done, then this job starts. This all trigger here means when all 3 of those jobs are done, then this job can start, okay? This UI here is pretty easy to work with. It was the easiest part to work with, I found. And it was just extremely straightforward. Having said that, I think in the real world, it can get quite complex, and this orchestration becomes vital because a scenario that I think is pretty likely to happen would be something like this. Feel free to jump in with thoughts of people that have done things like this, but if you've got a lot of ETL going on, a scenario might be this for sort of at scale ETL. You've got data landing in your raw S3 bucket from some other process. In Amazon, you've got a Lambda function, which is sniffing that folder to wait for a file of a certain name. When that Lambda process detects it happens, then it's set up to start this workflow, start this workflow starting trigger. All Glue workflows start with a trigger. And then, so that would be an event-based workflow, right? Other workflows would be scheduled, in which case you simply just schedule it here in Glue. Other workflows would be on demand, like in my case, it's just I run the workflow whenever I want to. But remember, all workflows start with a trigger, and best practices, all workflows should include a crawler within them, either in the middle, before, or after, to make sure that the catalog stays up to date. I'm going to pause for a minute. I'd love to hear some questions, and I'm also going to check to see what else it was I wanted to talk about. So I'll just pause and we'll see if there's any discussion that comes up.
Nope, I want to wrap up in the next few minutes here. Any questions while he's checking if there's any other closing thoughts for you all? All right, Daniel, wrap it up when you're ready.
Sure. Okay. So let's see. Things that I want to do more of and haven't yet would be to do more Spark SQL. Why? Because I'm a SQL guy. I mean, I'm okay at Python, but I'm good at SQL. Spark and Python pandas, for that matter, do pretty good SQL now. I've not demonstrated any of it. The stuff I demonstrated and the stuff that is auto-generated here in Glue for ETL jobs for Spark is PySpark data frames, basically, which is, for a SQL guy, it's a little harder to see what's going on. The code is a little less transparent, but I guess this is an example here that I'm working on right now. I haven't got it to run correctly because I had to present today instead of later. But typically, rather than having a nifty SQL statement in here, or rather than having all of this Python in here, if data frames and all of these, well, you have to have libraries, but if you set up your Spark to run Spark SQL, then you could run it in Glue as SQL transformations. What you won't get, though, is that handy dandy diagram and that little modularity there, and it won't be auto-generated. So you'd be generating the SQL, the Spark SQL on your own and dropping it in here. But I love that personally because now we're working in SQL. And when I want to have a left outer join and a whole bunch of subqueries, including a ranking function, I want to see it in SQL because then I know it's right. So that's, I guess in closing, the context for this for me is this is, in my mind, the crucial data engineering piece in Amazon that supports a lot of things. It could support loading Redshift. It could support loading Snowflake if you're using Snowflake. It certainly can support, from a data engineering standpoint, self-service. When you have people wanting to use SQL tools like Athena, which is also serverless, to do SQL queries and then either put that into Tableau or QuickSight and do visualizations. To me, this looks like a great way to dump a bunch of data into the data lake and then prepare only what's necessary, set up automatic jobs. As I've described, these can scale a lot, and then allow your analysts to do all the rest themselves. And one other thing that I'll close with is that Athena is very tightly integrated here with Glue, and analysts using Athena, if they're authorized to do so, can actually create new objects in Glue, meaning they can create new objects in S3. I would precede all of those objects with this word here, like I did. That's why for that job, or rather, I trained, I would train the analysts to put this in Athena, put this biz prefix before it, and to put it into a special S3 folder called biz. And so now we've got like a whole self-service repository going, and we've got our more reliable analysts who can actually create objects themselves. And that's great because you can save a lot of money. If your analysts have to do a massive join, don't you want them to do that once rather than every single day? You pay for it once and just have them do simple stuff after that. You're saving a ton of money. So I love this paradigm of serverless. I'd love to hear from other people if they've been burned by serverless or burned by any of these products I'm describing, because I'm personally still in the stage where I love them. I guess with that, I'll just say thanks. And this has been my learning experience with it. And I look forward to digging in deeper to all of them. So love to hear what questions you have. And thanks for giving me the chance. And I'll stop sharing my screen, that is.
Thank you, Daniel. Thanks for doing that on a bit short notice. I appreciate it.